Alright, so we're looking at simplifying radicals and performing operations with them. So the first thing that we want to do is find a perfect square that we can take out of the root if possible. So in example 1 we can see square root of 49. So we know the square root of 49. What times what is 49? Well, 7 times 7 is 49, so we know that the square root of 49 would be 7. So we have 7. Alright, so those are easy. If they're perfect squares already, we just take it and write it. So now what we have here, we have 2 times the square root of 144, so we need to think about a square root I can take out of 144. Well, 144 is 12 times 12, so we write 2 times the square root of 144, which is 12, and then multiply them together. So we have that 2 on the outside, so multiply, we get 24. Alright, so sometimes we're going to have fractions we're taking the square root of, so what we can do is we can write these as the square root of 4 over square root of 9. So we can take the square root of the numerator and the denominator separately. So square root of 4 we know is 2, and then square root of 9 is 3. Or we could just think of what times what would be 4 ninths, and we get 2/3. So go ahead and pause and try the checkpoints. So we need to think, so 225, so 225, we need to think about what times what is 225. So this could be a little tricky. So what you want to do is, let's try to divide out number that you think might divide out that is a perfect square. So like 225. So 225 divided by 25 is 9. So we have 3 times, and this is what you want to do. You want to write, so 25 times 9. Okay, if you can't think about what the square root of 225 is, it is a perfect square. But we have square root of 25 is 5, square root of 9 is 3, and when we take them out we want to multiply them, and we're going to multiply by that number that's already out front. Okay, so 3 times 5 times 3 would be 45. So at the very beginning, the other way you could do it, if you knew what the square root of 225 was, which is 15, you could multiply by 3 that's out there and you still get the 45. So there's a couple different ways to do these. You don't have to know all of your square roots. You can break it down and then multiply it together at the end. So square root of 1 over 81. So square root of 1 is 1. Square root of 81 is 9. Alright. So example 2, write each expression in simplest radical form. So that's what we're doing. So now we need to think about 112. So what times what would be 112? Well, we have 7 times 16. 7 times 16 is 112. And I chose 16 because it is a perfect square. So we could do square root of 16 is 4, so that comes outside. Square root of 7. Square root of 7 we're just going to leave like that because 7 is a prime number. I'm just leave it inside. So it's 4 times the square root of 7. And now we have 245. 245 is 5 times 49. Okay. 5 times 49, so square root of 49 is 7, and square root of 5 we can't do, so we just leave it. So 7 root 5 is the answer. And now we have 9 times the square root of 45, so 45 is 5 times 9. So square root of 5 times 9, and then we have that 9 outside. We know we can't do square root of 5, so that's going to stay. Square root of 9 is 3, so this is what we're doing. We're taking the 9 that's already out there, multiplying it by square root of 9, which is 3, and then square root of 5 stays inside. Multiply 9 and 3 together, get 27 times root 5. Okay. Go ahead and pause and try these checkpoints. Alright, so square root of 250. So square root of 250, well, there's something we could divide. We could divide out 25. So think about how many times 25 goes into 250. So 25 goes into 104 times. And you have, so that's a 10 times 25. Okay, so sometimes when you break these numbers up into factors that you know, sometimes you're going to be able to reduce it even further. You're going to be able to take out more perfect squares. So square root of 10 we cannot do, and then square root of 25 is 5. So 5 root 10 should be your final. And then 5 times the square root of 72. 72 can be broken up into 36 times 2. Square root of 36 is 6. We're going to do 6 times 5. So we get 30. And then root 2, we can't take the square root of 2, so that just stays inside. All right. Example 3, write each expression below in simple radical form. So square root of 1/3, we can do square root of 1, which is 1, but we cannot do square root of 3. So square root of 3 stays on the bottom, and we never really want a square root in the denominator. Okay, so some people think it's acceptable, but others do not. So we need to learn how to get it out of there. So what you want to do is you're going to multiply the top and the bottom by the square root that's in the bottom. So we're multiplying the bottom by root 3, and we're also multiplying the top by root 3. So we end up with the square root of 3 over, so square root of 3 times square root of 3 is square root of 9, which is 3. Or you can think squared. If we square a square root, that's also the inside number. So square root of 3 over 3 is in simple radical form. Now 2 over 5. So we have root 2 over root 5. Okay, again, we don't want root in the bottom, so we have to multiply by square root of 5 to the top and the bottom. Okay, so we have square root of 5 times square root of 5 is just 5. Square root of 2 times square root of 5, so we multiply the inside numbers and we get square root of 10. So if it were a number that we could break down like we were doing in the previous examples, we would want to do that. So pause and do the checkpoint. So we should have multiplied by root 2 to the top and the bottom. So root 2 times root 2 is 2. And then root 3 times root 2 is root 6. We cannot break that down, so that should be our final answer. Alright. So this last part, we're gonna get more into this later on. This is a quick introduction, so don't freak out if you don't understand, because we will get more in depth with this and talk about it. So imaginary numbers. So we have been told for a long time that when you take the square root of a negative number, it can't be done. So there was an imaginary unit. So it's called the imaginary unit, and it's I. This is made for taking square roots of negative numbers. So we'll take a quick look here, and like I said, we'll come back to this. So square root of negative 4. So we know the square root of 4 is just 2. So what we want to do is we want to break this up into 4 times negative 1. Okay, and then we can separate these. We know we can separate them because it's a product. So we get square root of 4 times the square root of 1. So square root of 4 we said was 2. And then the square root of 1 is this I value. So that's right here. It says I equals the square root of negative 1. So we're just going to write this unit I. Okay? And that's going to be our answer. Alright? So keep in mind, and we'll talk more about this later, but taking square roots, we have positive and a negative. But we're just worried about the positive one right now. We'll talk about the other later. So now we have a negative square root of negative 9. So we have a negative square root of, remember, 9 times negative 1 inside. And then square root of 9 is 3, so we have a negative outside. So we have the 3, and then the square root of negative 1 is I. Okay? Now, 2 times square root of negative 80. So we need to think of something we can split 80 up into. So we know it's 80 times negative 1. Okay. So let's think about what we could do with 80. So 80, we know 80 times, well, 80 divided by 20. 80 divided by 20 would be 4. So 4 and 20 we know works. Okay. Like I said, you don't have to have the perfect one, because we could break it up more later. Okay. And then we know 20 breaks down into 4 and 5. So we could write that 4 times 4 times 5. We know that's 80. I'm just going to leave this negative 1 hanging out in here. And then we can pull them out separately. So square root of 4 is 2, square root of 4 is 2. So we have that on the outside. And remember, we're multiplying everything together when we pull it out. And then we have this negative 1, which we could write as an I. And then square root of 5 can't be taken out. So now multiply these together, we get 8 square root of 5, and then I. Okay, so we could at the beginning we could have said, well, 5 times 16 is 80, and then we could have took the square root of that. All right. So again, we'll get more practice at this, but here's the last example. So we have negative 4, and then we want that negative 1 times 32 inside. Okay, so we know there's an I in there. So now 32, so we could break that up into 2 and 16. So square root of 16 would be 4, so that comes out. Square root of negative 1 is I, that comes out. And then we have square root of 2 left over. So we'll multiply all this together, so we get negative 16 times root 2, and then I. All right, well, ask me if you have any questions, but we will continue on this talk about I, and we're going to do more in the next video with radicals and operations of radicals.